Okay, so last time, so I'll go ahead and get started here. I'll make a little bit of earthquake noises, make sure mic is close to my face. Okay, cool. So we're doing the stream again. So last time we streamed, we worked the entire 2 hours on getting streaming support on Cobb's up and going. Now that is a thing already. So I finished up that PR. Let's pull that. What is it? It was cobs.rs, so it's going to be a welky. So I have 2 pull requests open. So there's the streaming encoder decoder. So I got that wrapped up. After the stream, I found a couple edge cases that weren't handled by my code at the time. Some stuff like what happens if a 0 comes in halfway in between processing a message. I think maybe 1 or 2 other things. We can look at what the commits are after that weren't in there. So probably these 2 commits, but yeah, so this is wrapped up. So hopefully this is done. The pull request hasn't been merged yet, so still have this vendor folder with this, but this has got the branch checked out. So when I actually add this to my project, I will use my vendor version for now, but I hope this does land and I can switch just using this as a cargo dependency soon. But for today's stream, I'm actually going to do the other half of what we were planning on doing last time, which is getting the DMA-driven UARTE up and going for this device. So actually what I'm going to do is I'm going to pull up a data sheet because that's what I like doing when I'm writing drivers and stuff like that. And yeah, just as a reminder, if you are watching this and you want to chat to me, I'm not paying attention to the YouTube chat because it takes too much CPU to be streaming and listening to myself at the same time, and it's very distracting. So if you hop on Rust Embedded, the Rust Embedded channel on IRC, let me see. Okay, here we go. It's kind of weird because this is on a different monitor. But yeah, Rust Embedded on irc.mozilla.org. I've got that up in a window, and I'm going to be looking at that. So let me pull up where I know this datasheet is on my computer, and then I will move it to the desktop so we can all see it. There's some talk about serialization. So someone is actually looking to do something really similar to what I was doing in chat. Someone named Aaron was wondering how you do binary serialization, and right now I'm going to use SS Marshall. There's also a crate called Scroll, which is really nice if you're implementing your own, like kind of manually serializing and deserialization. Also, I think Nom, which is a parser combinator, does work in no standard, but it may not be what you want if you're not writing your own parser. If you really just say, I have a struct that looks like this, and it should look reasonable, then using Serde is super nice for that. Okay, so I've got, where do I have this? This is in, go look through my downloads folder and find the right version of the datasheet. Okay, that's the datasheet that I want. So let's move this to the right desktop. Great. So this is Nordic's NRF52 datasheet. This is version 1.4. But yeah, if I need to look at how something is implemented in hardware, this is where I would look. Today we're going to be looking at UARTE, so I can actually look at what UARTE actually stands for. Make sure I'm not muted or anything. Come on, search. You can do it. Oh, with EasyDMA. So I guess the E stands for EasyDMA. EasyDMA is the DMA engine that Nordic uses. It's really nice because you, in general case, you have 1 DMA engine per peripheral, which means you don't need to do a bunch of configuration for like, this DMA engine slot is going for the UART, and we're going to do that. Which, you know, probably works really well. It is more efficient use of hardware, but as a developer can really be a pain to set up. But this is what we're looking to have going, and this, looking at this diagram, is probably healthy. in that we are going to be using easy DMA acceleration for our UART so that we can, just shove a bunch of data in and then let the hardware worry about sending it out 1 bit at a time, or 1 bit and byte at a time. And then also for receiving data, we also let it just handle that. Today we may only get the sending working on UART because receiving is a little difficult if you need data in real time, because normally with DMA you say, okay, 32 bytes here, go. And the problem is if someone sends 31 bytes, you're just going to not have any data available because the 32nd byte hasn't come in. And there's some ways to fix that using things like timers, or if it's been more than 100 milliseconds with no data, just flush whatever's in the DMA buffer. But writing the code for that is more complicated than just transmitting, because transmitting, we know exactly how much we're going to send at any given time. So we're going to do that first, and maybe if we're feeling super ambitious or if that goes very quickly, then we will do it a different way. But that's the goal, especially for logging. We just need to be able to send data right now. So we're going to do that to start with. So we're actually going to need to vendor. Let's clear this off, and I need to remember not to use anything down in this corner of my screen, because I realized that in some past streams I've been explaining stuff in a text editor here, so I need to know to keep out of this area. Maybe in the future I'll get a post-it note and make sure. See, do I have any piece of paper at my desk that's roughly the size of this window? Let's see if I can use this. That's too big. Okay, well, I'll get a post-it note or something for next time to make sure that I also know not to use this corner of my screen, but hopefully I will remember. So because we're going to be making changes to the hardware abstraction library that we're using, we're going to need to vendor that. So let's go and do that to start off with. And I realized last time that when I vendor using a Git or an SSH Git remote, CI does not like that. So I need to remember, since these are all public repos anyway, I need to remember to use an HTTPS submodule, and then I'm going to change this back because otherwise I'm going to forget. Yeah, normally, like, if you're just using open source everything, then the HTTPS works because you don't have to worry about authentication. So it will go and get the right information that you need, but sometimes I work on private repos which are not like that, which means you need authentication to work, which means you need to use SSH, or I'm sure there's a way to set up HTTPS to do it right, but I can't remember off the top of my head. So we're just going to use HTTPS. So cd vendor git some module add, let's add the whole, we're adding the whole nrf52 how, but we're not actually going to be using the whole nrf52 how. The way the nrf52 how is laid out is actually most of the nrf52 810, 832, and 840 have essentially the same peripherals. They have some details different in them, like the 840 has deeper DMA lines than the 832. The 832 can only send 255 bytes per transaction, whereas the 840 can do, I think, a full 16-bit, so 65K or so, or 64K or so of data at a time, where you can just say, here's 64K, go, and it will just go. But these don't really change how the drivers are implemented. So we have the repo structured where all of the common functionality, which is like 95, 98% of it, lives in this nrf52 how common repo, while all of the definitions of variables like consts, like how deep are the DMA lines, and if there were something that only exists on the 840 or one of the other boards, we would keep that there. But these are typically really thin. There's a libart, like this is the whole 810 crate where it just re-exposes how commons everything. We do this to keep the driver functionality consistent between all of them. So I am going to, what we're going to do is we're going to actually be working out of this how common, because this is where we define the driver, for example, the UART E. So I'm going to be working out of this, but the first thing I need to do is I need to tell Cargo, hey, don't use the published version of that crate, use the local one. So I forget this all the time, but cargo patch syntax. So Cargo as a build system has the ability to override packages. Excuse me. Where instead of just like replacing something you can just say, I'm going to patch this. So dependencies, yeah, so I'm going to patch crates.io because it's what the source is what you're patching. So I need to go over into my cargo toml for this. That's not what I wanted. Patch.crates.io, and specifically we're pulling in vendor how common. So the crate we're using, actually let's just do this, and then the path is going to be vendor nrf52 how. I think I need to specify nrf52 how common, and the version is still going to be 0.7. I guess this is implicitly getting pulled in by my board support crate dependency. This should be smart enough to replace this crate not just at the top level, but for all of the dependencies. So for example, the DWM 1001 depends on this crate. It actually depends on nrf52832, which depends on this, and by doing this, this should be smart enough where it will patch everywhere in the dependency tree where this shows up. So if I do a cargo build now, or cd2 sensor node, cargo build, I'm sure I have done something wrong. nrf52 how. So let's figure out where I have done this wrong. Burp, 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 burp. So this doesn't exist. This doesn't exist. That doesn't exist. Vendor? Okay. Sensor node vendor. Oh, right, it's up a directory. Right. Cargo build. Relative paths. Okay, so it's probably going to rebuild everything because, yeah. And we've also landed some PRs, like pulling in rand core. So someone very recently went in and implemented rand core. So we have the rand core trait implemented for the actual hardware random number generator on here, which is awesome. Let me see who that was so I properly credit people. Pull requests. Closed. And also the temperature sensor got implemented. But this was a chocolate, or Ferdia Mikio. I'm going to screw up that name, so apologies for screwing up name, but Chocolate. Chocolate went and implemented that. And Chocolate's been implementing a bunch of stuff recently, which has been really nice. I like when repos get better on their own. Not on their own. With the hard work of a lot of other people. But when I'm not the one that has to do it, I'm very happy about that. So this is still building. I don't actually know what is the FPA crate. That got pulled in with temp, but let's look up crates.io, crates, FPA. What is FPA while we're waiting for this to build? Fixed point arithmetic. Interesting. So Jorge wrote this. Let's go look at the documentation. I want to know what's in here. Using fixed numbers. Oh, okay, so probably where this comes from is the temperature crate was originally implemented for the NRF51, which does not have a hardware floating point unit. It only has a fixed point math, which means that doing floating point math is very, very difficult. So I'm guessing this is just a clever way of doing floating point math style things on a fixed point math, which means it's much more efficient. For, if I remember correctly, the 832 does have a floating, the 52832 does have a floating point unit, and the 840 also does, but I think the 810 does not have a floating point unit. I don't know if that's the 810 or the 811, but one of them does not have floating point, which is not very nice. So this has changed. This is where things are going to get complicated because other things have changed. So what we're going to do is we're going to go into our This is going to make everything rebuild again, but vendor how git log. So let's go back. There has been things that have changed in the last days, but let's go back to where the last release was, because that's what everything's based on. Git check out this, and then check out -b return of UARTE. So I'll start just a branch here that's tracking my changes to the UARTE, because I have an open pull request, but it's also old. I never got it merged. So I'm probably going to be copy and pasting some of the code out of that, but updating it with what the current state of things are. Yeah. So now I'm going to have to go sensor node, cargo, build. This is going to build again because now I'm telling you to undo all those compilation changes that it just made. But yeah, okay, cool. That worked a little bit better this time. So, but that's cool because we know the patch actually worked. So if I go into my NRF52 HAL and yeah, let's make a syntax error. Yep, okay, that is using the correct repo, which is nice. So what do I need to do? I need to probably pull in my changes. So what I'm actually going to do is, let's just open up another terminal for our vendor code. cd Ferris Internet of Streams vendor, and let's be lazy. And git checkout. What do I have? I'm gonna have async UARTE hack. Yeah, I think this is my old. Okay, so this is my actual old code. So let's HAL other. So let's look at what I have done here. So actually, I remember what I did is I split out this into two parts. I made UARTE. Oh, this is not the right repo. Did I not push that branch? Add UARTE 0, fix UARTE. So UARTE 0 git checkout UARTE 0 async. Load. Nope, that's also wrong. Okay. What did I do? Is this coming out of one of my repos, which doesn't exist here? Or did I not push those changes that I did? Pull requests. From UARTE async hack. Did my editor just not update? Maybe my editor just didn't update. So let's do this. And then project refresh folders. Because what I'm expecting was a UARTE folder which didn't have this in it. How other? So this is just the fun part where I get to figure out what's going on with Git. Because I thought I made a, yeah, NRF52 HAL common source. Huh? Is this coming off of? Is this coming out of this branch? Yes. Git pull origin async UARTE hack. Share pins, no more async features. Reorganize a bit. CD HAL common. If 52832 HAL cd source. Huh. What is going on here? I should delete some old branches. 6 commits ahead. So what do my commits look like this? No more async feature to test. So I should be on D5CB. So D5C 1CF 1CF. What is going on here? Because in this commit, I definitely introduced common source lib blocking, UARTE non-blocking. Should I just like not commit those new files at all? Okay, if I'm in, I know how we can check that. We can look at, I'm on async UARTE hack, how common source UARTE, and there are things here. What are you doing? Git reset hard head. I am entirely confused by what's going on here. So let's async UARTE hack. Oh, did I just, I bet you I did like a git checkout minus B or something? Huh. Git clone. Oh, that's not right. I am not succeeding at Git today. nrf52 HAL other git checkout async UARTE hack. Yeah. Project. Refresh folders. HAL other. Common source UARTE. Huh, that's really weird why it didn't do that. Maybe it really didn't like copy and pasting a Git repo. Maybe that is a thing. I don't know why that would be a thing, but maybe that is a thing. Okay, well, now I have it. So now I can essentially, what I'm probably going to do in, let's just start here. cd nrf52 HAL, cd common, cd source ls rm, what? Oh, right. Oh, that's probably what it was. Okay, git checkout return. It probably was some kind of symlink shenanigans. Maybe it's because it was a submodule and not a regular Git repo. That's probably what was going on. Okay, well that explains that. Didn't need to be on the stream, but it was. So now I'm here. I'm in source. Let's just rm UARTE. cp minus r common source UARTE. Okay, so now we have the UARTE, and it's going to be very confused. Well, let's go back here, and let's do a cargo build, and let's see how wrong this is. Okay, so there's been some other changes. That's okay. And we need to pull in my BBQ crate, which means I need to look at others, cargo toml. So I'll probably explain this in a little bit more later, but I have written a crate called BBQ. which is a bit buffer queue. So essentially it's a lot like a circular buffer. Well, it is a circular buffer, but it's a circular buffer where instead of inserting one item at a time, you can do a whole slice of bytes, which is really nice for DMA because that's how DMA works, is in slice of bytes at a time. So you can say, hey, give me a slice of 256 bytes that I can write to, and it will give it to you. And then you can DMA into it, and then you can say, okay, commit that, or commit part of that, that kind of stuff. So it's really nice for DMA. So let's copy this from this into, this is cargo toml. And I think 2.1 is still the newest version, but let's go check. Let's just BBQ. Version 3.2. No, we're moving up in the world. I've changed some interfaces and things like that, so this is likely to also break. But hey, what are you gonna do? Cargo build. Yep, I definitely changed some interfaces, but that's okay. Where's this vendor UARTE? Vendor UARTE. So let's go. Are you the vendor? I changed some stuff. That's okay. Vendor. Let's minimize this HAL other so I don't confuse myself. Where is this? Where is this failing? Source UARTE. UARTE mod RS. So let's go to the mod RS. Okay. P0 pin is now just GPIO pin, and then all of these become just pins. Okay, these are errors, so non-blocking grant. So that hey, give me 256 bytes. Those are what I've been calling grants. So we just need to do that there, and then so what I got rid of was, before, the grants would expose a field inside of the structure that was buff, that was the slice you can play with, and I got rid of that and implemented deref and deref mute. So excuse me, yeah, so w grant 168. So I need to make this a mutable grant. Okay, common output, expected input. All right, we fixed some other stuff. Common GPIO. What should you receive? Should be an input, expected type, output, but that's wrong. That probably got fixed somewhere. So I'm gonna have merge conflicts. That's pretty cool. Okay, where is this? This is in source lib.rs. Expected output. Found input, because input is correct. What's going on here? Did this get fixed? Burp, burp, burp. UM 1001. Commits. Release 010. No, you should be correct. And I'm using the cargo toml. I'm using the 070. Should I check out master or something? No. Git log. Tag 070. Right. So what is... what is this actually looking for? Into floating input. UARTE constrain. So UARTE constrain. Why does this not build? This should be just a clean into floating input that makes sense. Who is expecting this to be? UARTE pins. Ah, that's what it is. I broke UARTE because this is based on an old UARTE, so I need to go look at my UART. Mod RS. This should not be an output. RxD should be an input. And I think one of these also needs to be an input, but let's see what happens when we do this. Input. We need input. Cargo build. Set high. RxD set high. Well, yeah. Blocking. Oh, this is where we're gonna run into problems. Git checkout or git just pwd. This is in other, so let's go back. How other git checkout master. Okay, so we're going to use a tool that I like called bcompare or beyond compare. Okay, so let's actually do this off screen because I need to make sure that I have this done cleanly. So I'm going to Ferris Internet of Streams vendor NR52 how okay. Okay, so let's move this back now. Okay, so this is a code diffing tool that I like to use. So we're just going to diff that, and yes, very obviously these are different files, but I would like to compare blocking to UARTE. Quick compare. Open view. Okay, so parity, baud rate, easy DMA size. Oh, a bunch of stuff has changed. Okay. So let's do this, and let's do this. Let's do this. This is just going to make merge conflicts easier because this stuff has changed. And this can go away. I probably should just take the whole file because this is essentially, there's probably going to be some duplicate code in here because I refactored some of that to the lib, because essentially what I want is I want a blocking version of the I want the user to be able to choose between what they want. So what is all of this? This is read the UARTE. Okay, you know what? This just, you know what? Let's just take this whole file. It's going to be sort of wrong, but it's going to make life easier. If I was good at Git, I would do some kind of magical rebase on my old PR, which would be lovely. But I'm not, so I don't. So let's quick compare these. Open view. Oh, there are so many things different. But that's because this is a whole file and this one isn't. So I've got this. Ooh, timeout. We have a timeout now. Sure, let's take that. And this is that struct that changed. I guess an input push pull doesn't make sense. I probably need to do this for my non-blocking too. How do I write that code for non-blocking? Does it take a UARTE or does it take a UART? Where T is UARTE async ext and UARTE async ext is burp 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 for UARTE 0. So I am going to have to update some stuff in here too. Save, exit. So I also need to compare non-blocking to UARTE. Probably I should refactor this into like the core UART or something like that, and not duplicate a bunch of code, but the initialization is probably going to be different, so you know, win some you lose some. Isolate, let's take copy line to left. So I need interrupt, and NVIC. Control Shift L. So I guess here I don't need that stuff. And I'm doing some things some really ugly ways. I know I'm going to get rid of this and right, because we need to handle ports for the 840. I'm also going to need to bug Yateki to probably test this out on an 840 because I don't have an 840 board. So hopefully, I see you're in IRC, but hopefully you're listening to this too. And once I have this working, maybe I can bug you to test some stuff. You know what? I'm just going to end up having to eyeball this. That's okay. Okay, let's see how close we are. Cargo build. Yep, I know. UARTE mod RS. I thought I fixed that. No, okay, that's what it is. I didn't pull in the imports too. Input, push pull, floating. Yep. Constrain. Expected struct blocking pins, found struct UARTE pins. Do I need separate pins? I don't think I actually need separate pins. So let's, where is pins defined? Pins should be defined up here. And blocking should not define what pins are. So get rid of you, because blocking does not need to define that. Okay. Did you mean pin? I did not mean pin. Thank you for asking. Blocking. Pins. So that means I need to use create UARTE pins. Cool. Probably not entirely right. There's probably some 840 specific behavior that I'm going to need to think about that I have not dealt with yet. But hold on. Oh wow. Okay. We'll see how long I end up streaming, but okay, let's see how far we can get on this. So there's going to be, okay, so from a high level, what I'm doing here, let's actually explain this code because I haven't talked about what this code is actually meant to be doing. So what I do is I use a BB queue and I set up a queue and the way this works is whenever the DMA is done, you get an interrupt that comes back from that. And that interrupt says, hey, I'm done sending the data you asked me to, so if you have more data to send, then you can send that data, or you can queue it up to do that. Otherwise, you can say, okay, we're done. So what I've done here, and this is ugly code that I'm going to need to clear up, but I've defined the UART, or I've defined the UART interrupt, which just says, hey, whenever that kicks off, we're going to go here. So let me zoom out a bit. So we are given a producer and a consumer. So this is BBQ. It acts a lot like it is a single producer, single consumer queue. So it acts a lot like channels if you've used those on like desktop Rust. So they act this kind of the same way. So what this does is add initialization so that the consumer can define how big this queue actually is. We create a producer and a consumer, and that's given to us, and we kind of take ownership of that, where because this is transmit only right now, so we give the producer to the main context, so the user can do like uart.send. So they have the producer, so they can shove bytes in one end of the single producer, single consumer queue, and the interrupt on the other side can consume those, so they can take the data out. So we make a new one. We write async. Essentially, you pass in a TX buffer. It tries to get a grant, which is saying, hey, I want a TX buffer. I'd like this many bytes so that I can give you the data. And if that was successful, then it copies the data into that buffer. So we've essentially kind of made an allocation. So we're copying into the allocation in the circular buffer. And then we commit. We say, hey, that data is ready to be sent. So have fun. And then we immediately kick the interrupt. We say, okay, time to process the interrupt, which is going to immediately jump over to the interrupt, where because we don't have this is an unsafe function. I should probably constrain this a bit better, but we essentially kind of magically create another handle, which is not great, but it works in this context. We see if essentially a DMA transmission has ended, so basically it's still pending. If it is, or basically, did we just finish one? And if we finished one, clear the flag that says that was just finished. And if not, then it's going to keep going. So we get our maybe consumer. So because we have to share data between the main context and the interrupt right now in Rust, unless you're using RTFM, which we are, but this driver doesn't necessarily know that we're using RTFM. You have to kind of share the data somehow. And this is not totally sound the way that I'm doing this. It's fine as long as it's fine in the way that I'm using it. It is not fine in the general case, so Rust will not prevent you from making mistakes. So I don't know a better way of doing that, unfortunately. But we've got this for now, so we're gonna keep going on this, and if someone comes up with a better way, awesome. If not, then that's unfortunate. The way around doing this would be to essentially handle this all in RTFM, but that would be a really inconvenient user experience, which I wouldn't be a big fan of, but maybe we'll end up coming to that. We'll see. But so this is how we share data. This is essentially a global, file scoped global. So yeah, so we have to get that. Basically, if it doesn't, then we panic, which is fine. That means we've called the interrupt before we've done our initialization, which would be bad. So we've got our DMA state. So let's start cleaning this up. DMA state. Let's do DMA state idle. So then we have the DMA status. We swap that out so we can start figuring out what kind of state we're in. If a transmission just ended, or if a transmission didn't just end and we're idle, we're going to check for pending data and send that if possible. If a transmission just ended and we're idle, that doesn't make sense, so we're going to panic. So this is a true error state, but since we're an interrupt handler, we can't really respond effectively to the error state. We might set a flag, like a more idiomatic way might be to set a flag for the normal context so that we're not panicking in an interrupt handler, but for now this is probably also okay. Yeah, we should have a cleaner way of handling this, but it's okay for now. If we didn't just end a transaction and we have an active grant, then this means that we're in the middle of sending DMA stuff. So this probably means that someone just pushed more data into the queue, but we're already in the middle of sending stuff. So we're just going to say, nope, okay, cool. We're in the middle of something. We'll pick that up when we get to it. If a transmission did just end and we have an active grant, that means that we've just completed a DMA transaction. So we need to then send some more stuff. So we check how much we sent. Right now I got rid of this assert, but essentially we then say, okay, FIFO queue, I just got done sending 128 bytes or whatever it is. So release the minimum of either how much we expected to send or how much we actually sent. So this way we make sure that we never like pop more items off than makes sense. So then we try and get the largest read grant in there, which means, you know, I either got some amount of data to send or this, and if it works, so this probably needs to be to do use 255 is only for the 832, use JIP specific numbers here. Actually, this is just that DMA size. I think I pulled that in. Did I import that? Did I import that in lib? This is the wrong lib. I wanted mod, not lib. No, I bet I only pulled that in non-blocking. Excuse me, blocking. Okay, how many easy DMA size? Where do I define easy DMA size? This is what I want. This is what I want. Non-blocking. I'm gonna have to clean all of these up. Oh, it's right there. Awesome. Thanks, go me. So 255 min that. Cool. So now this is no longer needed. So we've got some compiler fences. We set up the DMA and we start it. Use DMA state. I guess DMA state's already here, because it's defined in this file. We are literally in that file right now. And then I know it's going to complain about. Actually, you know what? This is fine. I'm okay with this. What was all here before? Equals idle. So do I do stat equals idle still? Yeah. This is one of the annoying things, is enums need to have their fully qualified name, which means that in match statements it gets really big. Yeah. So do we still build? UARTE blocking. Blocking doesn't need all of this because this is going to be handled one layer up. And we still have format. That's because I haven't implemented something there, but that's okay. So non-blocking. Okay. So. What do I need to be doing here? I need to be doing something. Okay, so let's go to our actual example now, because we're gonna want to make a serial port. So yeah, so I can go to my sensor node. Now we're actually back on our hardware, which is nice. So I need to make a UARTE. So actually I'm gonna go look at the DWM code. In source, lib.rs, UARTE. Where do I make a UARTE? Okay, so this is essentially what I need to do. So static mut UARTE is going to be a UARTE of UARTE E0, I think. This is going to be a late resource. So again, we're using RTFM, so it has late resources. So what am I going to need? I'm going to need DWM, how, I need UARTE. I'm going to need timer. Okay. So I'm going to need UARTE. How do I export that? I export that as UARTE async or something. Pub use crate UARTE non-blocking star. Do I already have this in this file? Pub mod. Oh no, that's right. I don't want to do that. I just want non-blocking. That's fine. Main.rs. So I want UARTE non-blocking UARTE async. UARTE async ext, which is the extension trait. Pins are going to be the same, so I need UARTE pins non-blocking that at. Yeah, it's complaining about late resources. That's fine. And then from this, I'm also going to need TU UARTE 0. Okay, so let's do that's fine. So back here, let's just steal all this code and put it somewhere in here. I'm going to need UART parity and baud rate. This is wrong, but UARTE 0 or just UARTE equals UARTE 0. Could not compile. P. That's because the peripherals don't exist. Because it's not peripheral. Let's see. Did I pull in pins? I did pull in pins. So pins exists. P is actually device. Pins. Okay, cool. I do make pins actually. UARTE not found in the scope. That's because it's UARTE async. Right. Because this needs to be that. Blocking UARTE. Why are you blocking UARTE? Because I used block UARTE async. Device UART constrain. Parity baud rate. Because the constrain comes from UARTE async ext. I don't have the other X trait in there. So where are you getting the fact this should be UARTE async is my type. So it's probably because we have the wrong signature here. Because UARTE should be a UARTE async UARTE 0. Oh, is it constrain async or something like that? Did I get clever with impl new? Where is my extension trait? Constrain async. That's right. I did that so that it wouldn't get confused because there was two methods that have the same, or two traits that have the same method name. Expected 6 parameters. That's good because that's what I expect, because non-blocking is going to need, it's got NVIC, pins, parity, baud rate, producer, and consumer, which means I also need to make my let's see, BBQ Rust. I need to statically create this, so I'm gonna have in my, let's see, this is gonna need to use BBQ, but then I know I'm also going to need to cargo toml BBQ needs to become a dependency of my main project. And then my main can use BBQ. Specifically, it's going to use BBQ, which is a macro, producer, and consumer. It actually doesn't want to use the BBQ macro. I should use the BBQ Cortex M. Cortex M. And I think I need to set a feature for that. Source. Cargo toml. Did I create? Cortex M. So I need to enable the Cortex M feature. Cargo toml features equals Cortex M. Which means now in my main I can use the Cortex M BBQ. So I should be able to, I need to do it above this. Let BBQ equals Cortex M BBQ. Let's give it, how much space do I want? I don't want like 2048 or something like that. Let's give it 2K to play with. And I think this has to be unwrapped. Unwrap. And then let P C equals BBQ dot split. And then I need to do what? I need to give it producer and the consumer. Cortex M BBQ. Undeclared type or module Cortex M. Oh. Cargo toml. Do I need to explicitly call out Cortex M 08058? Cortex M. This is because it needs access to a primitive that exists in Cortex M because it uses a mutex, which is probably overkill here. But then, yeah, what are you going to do? So use Cortex M. Undeclared type or module BBQ. Okay, I guess my macro leaves something to be desired in practice. Constrain async. I guess we don't need producer and consumer. Expected 6 parameters, but 5 were supplied. What? I need the NVIC? Oh, I guess it does need the NVIC. Why do I need the NVIC? It's a little silly that I need the NVIC. What do I actually use the NVIC for? Huh. Do I have access to the NVIC? Or does I worry that that's going to be a core peripheral. What happens if I hand it? So where's what? That's after UARTE. If I start constrain async pins. So constrain async is what I need to actually look at. So it needs to be the first item. Okay. Core and core dot NVIC. Is that a field that you have? Yeah, you don't expose that, do you? So let's actually get rid of that, because I know I don't actually need that. The idea was that you had to prove that you had ownership of it, but I need to get a better chair. NVIC. Instead of NVIC enable, we need to do NVIC enable. Ooh, or is that going to complain because expected 7 parameters, found 6. Non-blocking. Trait requires 7 parameters. It's weird that you picked that line. I probably just didn't update my actual parity. Yep. I don't think RTFM gives you the access to the NVIC. So I can make my own, but that's going to be... Okay, I'll make my own. Let's see. Okay, non-blocking. Change this all back. This is really... Well, this is why I'm doing this on the stream, is because I want to find all these ugly spots when I'm doing it, because this is actual use case, so it tells me whether my design has been good or not. So what do I need to do? In here, I need to unsafely create a unsafe and mut. Let's see, what am I gonna do? I'm gonna do NVIC putter. Let's see how much it complains. I can't remember what the NVIC is gonna be defined here. Putter. It's probably gonna need to be a mute. Ow. You're what? NVIC register block. Oh. This is star const as star mute. As and mute. This is evil. I don't think this actually works. There's a way. Yeah, because I can't just make an NVIC out of air. Huh. Okay, well, I'm going to have to wrap up here in a minute anyway, but... Yeah, so that's going to need the NVIC because I need to be able to enable the interrupt. But I can't just create an NVIC, and as far as I know, RTFM burp 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 NVIC. Let's search for NVIC in here. I guess if I have the register, I don't want the register block. The register block would work, but it wouldn't be great. Let's see, it's just called core. Init core and device variables. NVIC, do you talk about what ones you systic, maybe? What is RTFM peripherals? Okay, let's actually look at Cortex M RTFM. Let's find peripherals in this repo. RTFM peripherals, not in tests. I need see RTFM peripherals. Oh, yeah, that would make sense. I need to go look at the API reference. I should probably open up an issue that talks about how you get stuff like this, because there are stuff in core peripherals. The NVIC field is never present. Okay, so yeah, I'm not a fan of this. Well, I'm a fan of RTFM. I'm not a fan of what's going on here, in that it doesn't give you the ability to have access to these fields, because it uses that, rightly so, but in init it probably should. Maybe an unsafe method that gives you access to it. Or I'm going to have to rethink how I do my interface for the UARTE async, which might be how I do it. But yeah, I was hoping to just drop this in here. Okay, well, this was an hour. So to wrap up, where we got stuck is I have kind of cross-ported the old async code, and I've updated it a little bit, but it needs to be cleaned up a bit. I've got the BBQ stuff dropped in there, but the problem is that when I create the UART, the way that I've got my async code going right now is that it takes the NVIC, so you enable the interrupt because it owns the interrupt, but you can't have the NVIC here. What I may end up doing is, well, I'm gonna take a step back and I'm gonna think about this. I have run out of time for today, so unfortunately I won't finish this day. So this is part 1 of getting UARTE going DMA driven, and it may kind of force my hand into accepting a slightly less good interface for how you handle this interrupt, or maybe I just provide a callback function or something. But I'm gonna have to step back and I'm gonna have to take a look at how I structure my interrupt and stuff like that. Maybe open up an issue with RTFM to see if they would be interested in having a method that gives you access to the peripherals that it's reserving in the init function. But yeah. Okay, well, let me check real quick on YouTube to make sure there weren't any questions that I'm not paying attention to. And if there are, then I am sorry, but I did say that I was only going to look at the chat, and there's been a couple comments, but no actual questions in the chat. So let's go to live stream, and I'm probably going to start hearing myself talking. Yeah, let's pause that. Mute. Okay, doesn't look like there's any chat comments there, which is good. So just the stuff that's in the, IRC. So, okay, that'll have to do for today. So thanks if you've been watching, and if you're recording, leave me a comment if you have any questions, and this will go into the folder of part 1 of getting UARTE up and going. Okay, thanks for watching.